Hi class, today is the 10th of June, and as I mentioned yesterday, we're going to be recording a video here. It's going to go over just the beginning parts of Lesson 9 in order to help you get on your way into learning how we're going to be graphing these functions and how just looking at the equation itself will be able to help us graph them. So the first thing we need to do is we need to consider this equation that we have here. They give us the equation y is equal to x squared plus 6x minus 40. Given this quadratic equation that we have here, is it possible to find the points where our graph crosses the x-axis? That's going to be both a yes and kind of a little bit of a no. The no comes from, so long as it's in this form, we won't be able to really find those points where it crosses the x-axis. So we're going to actually have to take this and put it into a different form in order to help us find those points easier. Now, what we need to also think about is where will the graph cross the x-axis? Remember, these are our x-intercepts. And our x-intercepts is where it crosses the x-axis, also where y is equal to 0. So we're going to have to think about that. But first thing we are going to have to do is we're going to have to take this and we are going to have to put it into a factored form. So again, what we want to do for a factored form is we want to find out where we are going to add up 6 and multiply to negative 40. So let's list off all of my factors of 40. I've got 1 and 40. I've got 2 and 20. 3 doesn't work, but I've got 4 and 10. I've got 5 and 8. 6 doesn't work, 7 doesn't work, and 8 we already have listed. So these are all of my factors of 40. Now, since we have negative 40, I know that I need one of my numbers to be positive and the other number to be negative. Now, which numbers, when I combine them, is going to give me 6x? Well, that's going to be my 4 and my 10. 10 plus negative 4, or 10 minus 4, gives me that 6. So that means on one side, I'm going to have x plus 10. And on the other side, I'm going to have x minus 4. And that is going to, of course, be equal to y. But we already discussed this. We want y to be equal to 0. Okay, so that means that 0 is equal to x plus 10 times x minus 4. Now my question is, if I want this to equal 0, how do I get 0 when I'm doing multiplication? There's only one way to get the number 0 when I'm doing multiplication. One of my two things needs to be 0. That means either this first section needs to equal 0, or the second section needs to equal 0. So that means that x plus 10 is going to be equal to 0 for one of my x-intercepts, and x minus 4 is going to equal 0 for my other x-intercept. Luckily, these equations are super easy for us to solve. It's going to be x is equal to negative 10, and x is equal to positive 4. So now we've got our two x-intercepts. I've got x equals, wait, slow down. X is equal to negative 10, so I have negative 10, 0. And over here, x is equal to 4, so I have 4, 0. So I've found my x-axis. I found my x-intercept where we cross that x-axis. Now, the good news is, since I have my equation here, and I have these 2 points, we could talk about this. In our last lesson, we learned all about our symmetrical nature of our graph, how it's reflected along a line of symmetry. How can we use that information to find the vertex for our graph? Well, I know that my vertex has to have an x value that is halfway between I know that the x value of my vertex needs to be halfway between the x values of my x-intercepts. So what is halfway between negative 10 and positive 4? Negative 10 and 4. I'm going to do this the long way just to show it off. Negative 9, 3, negative 8 and 2, negative 7 and 1, negative 6 and 0, negative 5 and negative 1, negative 4 and negative 2, and then we meet up in the middle here at negative 3. So that means that my vertex is going to have an x value of negative 3. But how does that help me? I need my full value for my vertex. Knowing that x is equal to negative 3, that only gives me really my line of symmetry. Doesn't actually give me my vertex. Lucky for us, however, we know what our equation is. So since we actually know the equation itself, we can just take negative 3 and we can plug it into our equation. So y is equal to negative 3 squared plus 6 times negative 3 minus 40. So y is going to be equal to 9 plus negative 18 minus 40. And then if we combine all of this, we're going to get the y is equal to negative 49. So I now know my vertex. My vertex is going to be negative 3, negative 49. And now we have 3 points. Technically, once again, that's kind of all that we need, but we can go even further and get some more nice points for us. For example, part C is asking us how are we going to find our y-intercept, which is where our graph crosses the y-axis and where x is equal to 0. Oh, well, they just told us x is going to be equal to 0. So let's take x and plug it into our equation. I want to plug it into our factored form equation because it's going to be a little bit easier for us to do. Factored form equation, as a reminder, is going to be x plus 10 and x minus 4. So plugging 0 into this, I get 0 plus 10, or that's just 10, times 0 minus 4, well, that's just negative 4. So y is going to be equal to 10 times negative 4, which is negative 40. So my y-intercept is going to be 0, negative 40. Now we have 4 points. But here's the thing. We're not done yet. We can actually get a single more point to help us out. What else can we say about our graph based on our knowledge of the symmetrical nature? So this is the thing that we're going to touch on. The symmetrical nature of our graph of a quadratic function. How can we determine the coordinates of any other point? Well, here's the super great, fantastic news. We're going to look at our y-intercept here. And we're going to ask ourselves, well, how far is our y-intercept from my line of symmetry? Remember, that line of symmetry we found out is x equals negative 3. So to get from 0 to negative 3, we have to go 1, 2, 3. Okay, so let's go 3 in the opposite direction. 1, 2, 3. Negative 6. So, since it's symmetrical, we know that negative 6 has to have the same y value as our y-intercept, aka negative 40. So we actually have 5 points that we can take and we can graph. And of course, if we truly wanted to, we could plug in every other point to the equation that we already have and use that to help get an even better representation. Now that we have all of our points, what we're going to do is we are going to, well, graph them. We're going to take those points and we are going to plot them on this grid here, and we're going to connect them to show the graph of our equation. So I'm going to make my graph look something like this. And since we have a lot of negative numbers here along our y, what I'm going to do is I'm going to give the y a little bit more space for our negatives. And let's plot our first 2 points. The first 2 points that we found were our x-intercepts. I'm going to have each square along my x represent 2. So we've got 2, 4, 6, and negative 2, negative 4, negative 6. But since I don't have as much space and I have much larger numbers along this one, I'm going to have each number here represent 4. So I've got 4, 8, 12, negative 4, negative 8, negative 12. So that I'll be able to fit it all onto this smaller grid that I have. So my points for my x-intercepts, I have this one right here at 4, 0. And I have this one over here at negative 10, 0. The next point that we found was our vertex. It was along our line of symmetry, which lies right here at where x is equal to negative 3. And it goes all the way down to negative 49. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. So 49 is going to be right around here. So our x-intercept should be right around there. X-intercept, our vertex. What we need to find next is our x-intercept, which, if you remember, was at 0, negative 40. So we know that we're just going to have to go down 10 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this point right here is at 0, negative 40. And I'm going to make sure that I don't forget to label this one. This one's at negative 3, negative 49. And then the last point that we have is our symmetrical point over here at negative 6, negative 40. Now that I have all of my points, I can make a nice U-shaped graph out of them. And of course, since we don't have any other points, this is technically going to be a sketch. And if we wanted to get more points, we could have, in order to get an even more accurate graph. This graph right here is more than capable enough. Now, what you guys are going to do today, there's not a lot of work. All you guys are going to do is you're going to do exercise 1. For exercise 1, it's going to give you some equations. You are going to use those equations to give us some of those key points. So, just like how we found here, you're going to give us our x-intercepts. You're going to give us our vertex. You're going to give us our y-intercept. And then you're going to give me the extra point that we can find out because of our symmetry with that y-intercept. So with that, I'm going to leave you guys to that for the rest of class. For tomorrow's class, I'll record another video about example 2 and then leave you guys for the next couple of chunks. Farewell. Have yourselves a great rest of your day.